Hello everybody. In this video we are going to talk about the construction of the LR0 parsing table. So as mentioned earlier, LR0 is a table based parser, so we need to construct the table. And to do this, we have already gone through this part. That is, we have to first augment the grammar by adding a new start symbol. Here we are calling it A dash. Then we have to construct the LR0 set of items, the closure and the goto, and we get this DFA. Now, here in this DFA, I have 6 states. We have deemed them I0, I1 up to I5. Now, in any DFA, you know that there are certain states which are final states. So, in this DFA also, we have certain final states. So the final states will be the one which has the dot at the end. Remember what the dot means? The dot means that you have scanned everything that comes before the dot. So there is nothing left to scan, okay, if the dot is at the end. So you can see here, this one is a final state. The one here also is a final state because the dot is at the end. Similarly, I5 is also a final state. So these are the final states. For all the others, you see the dot is not at the end. It is somewhere either in the beginning or in the middle. So these are non-final states. And of course, our start state is I0. So once we have this, next we have to construct the parsing table. So to do that, so this is how our parsing table looks like. Okay. For every state in the DFA, we have to have one row. So 6 states, so I have 6 rows marked 0, 1, 2, 3 up to 5. And the rest of part of the parsing table is divided into 2 sections. The action section, where for each terminal symbol, you have a column. So our terminal symbols in our grammar was opening parenthesis, closing parenthesis, A, and of course our end of string input symbol, that is $. And in the goto section, we have one column for every variable. So with this ready, now let us construct this table. So to construct this table, we need to refer to our DFA. So this is our DFA. Now we do not consider the augmented grammar anymore. We only consider the original grammar, which was this one here. So here I have 2 productions, right? I have production A parenthesis, okay, and A derived small a. So we can mark them, say this one is 1 and this is 2. So we just give a number to the production, okay? Now we start with state I0. So in state I0, okay, we have to see what the transitions and what is the label of the transition and where does it go. So if you take the first transition, the label is A, that is, it's a non-terminal symbol, and it goes to state I1. So we will go to our table, and then on state 0, for this particular row, on A, that is this, this goes to our state 1. So we will write 1 out here. Okay, so because it is labeled by the non-terminal symbol A. Next, for I0 on small a goes to state I2. Okay, so state 0 on A goes to state I2. So what we'll write here, we'll write shift 2, S2. S stands for shift, 2 stands for state number. So shift 2. Then we'll see one more transition is there. This is labeled with opening parenthesis. So I0 on opening parenthesis goes to state I3. So I0 on opening parenthesis goes to state I3. So shift to 3. That means move to 3. Okay. I0 doesn't have any more transitions. That's it. Now we'll go to the next one. So next state is 1. So I1. Now I1, you see, this is a final state. And that too, it is not just any final state. It is the final state for the augmented start symbol, A dash. So what it means that you have finished scanning or you have reached the start symbol of the original grammar. And that is when you have to either accept or decline. Okay. So if you have reached the start symbol of the grammar, remember this is bottom-up parsing, so you stop when you reach the start symbol. So when you have finished scanning and you have reached the start symbol, okay, then that means you have to accept. Now accept when you get the end of the input. So 1 on dollar will be accept. Let me write A. Don't be confused with the A symbol here. Okay, let me write here ACC. So that means 1 on dollar is accept. So let me just repeat. A here, this is not just any final symbol, final state. It is the final state of the augmented, the start symbol of the augmented grammar. So for such a set, if this is the state, then you have to accept on dollar. Next, we take state I2. For I1, there are no other transition. There cannot be any other transitions. So we stop I1. Next, I2. So I2 here also is a final state. Okay. So when we reach a final state, then what we can do? That means we have reached the end of this particular production. A derives A dot. So we can now reduce A to capital A. So we will write, so now this is not a shift move, it is a reduce move. So reduce by which production? Production number 2. So we will write for state 2, this was state 2, I2. So for state 2, we'll write reduce 2. So reduce 2. Here reduce means you understand. You reduce using a production, and 2 is the production number that you want to reduce. And this will be written for all the symbols. Okay. So reduce 2. Next, so this is a reduce move. So reduce you will put in all the columns of the action section. Next, we are in state I3. Now in I3 we have three transitions. One on capital A. Okay, this moves to state I4. State I4. Okay, so we will write in the go to section for state 3, and the go to section, it means that on A it goes to state 4. So 3, you will say go to 4. What about the other transitions? On A it goes to I2. So on A it goes to I2. On A it goes to I2. So shift 2. Okay. And on opening parenthesis it goes to itself. So shift on opening parenthesis, shift 3. Okay. Shift we will put only on those columns which is the label of the transition. So here this transition was labeled with parenthesis, so we'll put shift only in that particular column. So no more of state 3 I3. Let's look at state I4. State I4 is not a final state, and it has got only one transition, that is on closing parenthesis to I5. So I4 on closing parenthesis will shift to I5. Shift 5. Okay, and I have I5 next. Now I5 again is a final state, so it is going to be a reduce move. So in the reduce move, which production we are going to reduce it by? Because this is A derives A parenthesis A, then dot, so we'll reduce it by production 1. So reduce 1, reduce 1, reduce 1. So this is how you can construct the parsing table for LR0 parser. So a quick recap or summary for constructing the table: have one row for each state in your DFA and one column for each terminal and dollar in the action part, and one column for each non-terminal in the go-to part. Then follow the transitions from the states, and if it is labeled by a non-terminal, then put that non-terminal put the transition in the go-to section. Otherwise, put it in the action section. Now there can be only two types of actions, shift and reduce. So if the item is not a final item, then you use shift to that particular state, and you label it and you put it under that particular column, which is the label of the transition. And if it is a final state, then you use the reduce move. So if it is reduce, then you have to put it across every column of the action part. Okay, and then you have your table which is ready. And if the final item is one which is the final item for the augmented production, then you are going to accept on dollar. So this is how you construct the parsing table for LR0 parsing. Very quickly, let us take an example and see how this parsing will work. So here I have an input and I have the stack. So I have parenthesis, parenthesis A, parenthesis, parenthesis, dollar. And I have in the stack, I have dollar, that is this empty stack will have start with dollar, and it will have the start state 0. So now we are not going to have only the terminals and non-terminals in the stack. We are also going to have the states. That is the main difference between this and LL1 parsing. So you have $0, parenthesis, parenthesis, A, closing parenthesis, closing parenthesis. So we will match now A0 on opening parenthesis. So we'll see the table 0 on opening parenthesis is shift 3. So what we'll do, we'll shift parenthesis, and we'll shift in also the state 3. Okay, so I have this left. Okay, so we shifted not just the input symbol, current input symbol, we also shifted the put in the state. Next we have 3 opening parenthesis. So 3 opening parenthesis, it is shift 3 again. So $0 parenthesis 3 parenthesis 3, and here I have this remaining. So again now 3 and A. So 3 on A is shift 2. So and you are left with these. Okay, now 2 on closing parenthesis. So 2 on closing parenthesis. Now 2, you can see it is reduced. So 2 on closing parenthesis is reduced, R2. So reduce 2. So we will use here now 2 is this, will reduce by this. That means A will be replaced by capital A. And what about the state? The state would be whatever is there in your go to. So let us put this 0, 3, 3. So A here would be replaced by this. Now what about 2? Now 2, instead of 2, we will see what is there at the bottom. So 3 is there. So 3, this 3, so 3 on A is what? Go to 4. So in the go to section we have 4 here. So 3 on A is 4. So 3 on A, that is 3 on A, will be 4. So we have a 4 out here. So we have this left. That is where we are using our go to. Remember, we'll use our go to whenever we have done a reduction, and then based on the symbol what you have here and what was there at the top of the state at the top of the stack, based on this you look at the go to section. So we got 4, 3 on A goes to 4. So 3 on A goes to 4. So we put 4 out here. Okay. So now what we have? 4 on closing parenthesis. So 4 on closing parenthesis is shift 5. So $0.333A. We have 5. So we have this. Next, 5 on closing parenthesis. 5 on closing parenthesis is, again, it's a reduce. So 5 on closing parenthesis is reduce. So what we will reduce? This we have here. So here we have to do a reduce by 1. So 1 is this. Now, how many items do you have to remove from here? When you say reduce, then our reduce would be, we will have to reduce by this, all 3. So I have 3 symbols. Opening parenthesis, A, closing parenthesis. So here you see I have opening parenthesis, A, closing parenthesis. So I have to remove these 3 so that I can reduce this part by A. Okay. But along with it, you also have the states. That is this, this and this. So if you have 3 symbols here, okay, you have to remove 2 times this, because one's for the symbol itself and other is for the state. So I will remove 5 parenthesis, 5 parenthesis, 4A, 3 parenthesis. So all these will be removed. So we'll repop these elements from the stack. So earlier we had popped here, it was one element, so we popped 2. As you can see, we have popped 2. So A and 2 had been removed. Okay, so here we have popped all of these. So look something like this. Something like this. Okay, I still have parentheses here. Now what would be, what will we have? We are replacing this by A. We have popped out these 6 elements and we have pushed in our right hand side, that is A. We have pushed this in. So now I have A here. Now I have to put a state. Now what would be the state? 3 on A. 3 on A. So which is 4. 3 on A is 4. So this is the 3, this is the 8. So 3 on A will go to 4. Okay, so we have this. 4, the state 4 is pushed in. Next, 4 on closing parenthesis. So 4 on closing parenthesis is shift 5. So 4 on closing parenthesis, shift 5. Okay. Now 5 on dollar. 5 on dollar what? Reduce 1. So reduce 1. So again I have to reduce by 1. Production number 1. So 3 elements means I have to pop out 6 elements from the top of the stack. So which ones? 1, 2, 3, 4, 5 and 6, and replace it by A. So $0 A and dollar here. Now A on dollar, you see, dollar on 0 on A, 0 on A, go to 1. So 1 will come here. Now next step would be 1 on dollar. So we see 1 on dollar is what? Accept. So what we get here is a accept. So we have successfully parsed the string using LR0 parsing.